Okay, so this is the slope fields worksheet 2, and it is 2 different AP free response questions that have a part A, B, and C, and I've just selected out the parts A and the B to work on the specific skill that we're talking about with slope fields. We'll eventually, or in the next section, talk about part C. So in this one, we're given an actual slope field, and like I talked about in the previous video, the AP has put dots where they want you to draw little slope slashes, and they've asked you specifically within the directions to do 6 of them. So let's grab a red pen, and we're going to draw 6 points indicated, and we've got our differential equation right here that tells us what the slopes are worth. So let's start at 0, 0. So if we start at 0, 0, we're going to have a 0 on top of our slope equation. We'll have a 0 minus 1 on the bottom, which is of course 0. So we get a little flat slope right there. If I move up to 0, 1, I've got a 1 up top, and I've still got the 0 minus 1 on the bottom. And let's see, that's now 1 divided by negative 1, which is negative 1. So I've got a negative 1 slope that goes through there. And then we move up to 0, 2. So I've got a 2 up top, squaring that, still my 0 minus 1. So that's a 4 over a negative 1, which would be negative 4. So it's steeper yet. And that's going to be good for the AP. They just want to see you can designate negative slopes. They're not worried about your 1 versus your 4, although ideally you show them it's a bit steeper, and then you get your flat slope correct at 0. And we'll shift over to the column at 2. So we'll go to our 2, 0. So now our top is 0, and our bottom would be 2 minus 1, which is still 0. So we still get this little flat slope snippet. And then we're going to do 2, 1. So we'll have our 1 up top, 2, 2 minus 1 on the bottom. So that's 1 over 1, which is 1. So then we've got a slope of 1 right there. And then finally we're going to go to 2, 2, which gives us a 2 squared up top, 2 minus 1 on the bottom, which would give us a 4. And you don't need to show them all this work. I'm doing that to demonstrate to you where it's coming from, but you don't need to do all that. What you do need is this thing filled out. So on the axis provided, sketch a slope field at the 6 points indicated. Did it, done, good to go. We're not asked to do anything more with that. And in part B, they're giving us an initial condition. So they're going to talk about f of 2 is 3. They are not asking for us to sketch that initial condition in. They're saying let y equal f of x be a particular solution or a solution. Just think solution to the given differential equation with the initial condition. So they're saying there are functions that work up here. This specific one we're going to look at has f of 2 equal 3 on it. So then write an equation for the tangent line to the graph of y equals f of x at x equals 2, and then use your equation to approximate 2.1. I want to make it really clear here. They do not want you, they are not interested in you finding what f of x equals. They simply want you to do a tangent line. So a tangent line to f of x is this generic format that we have seen time and time again. And they gave us an initial condition. They gave us 3 for y. They gave us 2 for x. And then they gave us an equation that we can go ahead and get slope with. So our equation for slope, our differential equation, is right up there, y squared over x minus 1. So use it to get our slope. Let's see, y would be 3, so we're going to square that. X would be 2, so that's going to give us 9 over 1, which is just 9. So our tangent line equation would look like this. You can write it like this. You do not have to y equals mx plus b it. If for whatever reason that just you feel the need to do that, you can generate that expression. That is absolutely fine. It is no better or no worse if you add a 3 to both sides after having distributed the 9. So I'm actually going to leave it like this. But you could do the rest of it if you wanted, as long as it's equal and it holds up. Now they're asking us to plug in a 2.1. If you did y equals mx plus b, you can plug it into that equation. The reason I like this, leaving it in this format, is 1, I don't make a potential mistake. 2, I can do the 2.1 minus 2, and that typically they set you up to make that an easy or easier by hand computation. 2.1 minus 2 is 0.1. You multiply 9 by that, and you're going to get 0.9. And then you add a 3, and you're going to get 3.9. And that's it. We're done with the problem. Again, we could have gotten that same value out of our y equals mx plus b. I just think it's a little cleaner to do this way. There's a solutions worksheet up as well online that you can actually see how the AP structures their points. So this video is just to show you how to do it, and then the AP scoring structure you can check to see what specific things they're tagging points to. But pretty much as long as you're showing your work and answering their questions, you'll get full credit. You just have to be careful to show steps like we did in part B. And let's see, so that was the part 1, or the first of the 2 questions. The second of the 2 is giving you a slope field. So on this one, they're not having us sketch it. They're giving us a differential, but they're saying, here's the slope field. And they went really aggressive with all those little slashes. But specifically what they're wanting to do, or what they're assessing here, is can you take these 2 different initial conditions, so 2 separate ones, and draw what the curve would look like. And they even put a little dot at each of those spots. So we've got a little dot here at 2, we've got a little dot here at 1. And they're saying just from those points, sketch it in. So at 2, you can see all the slopes are 0. If you don't believe they're all 0, you go to the differential equation. For all the y values of 2, you're going to plug in a 2 there. You're going to get 2 minus 2, which is 0. So that zeroes those all out. This, when you get a flat line like this, it is called an equilibrium solution. They rarely leverage this particular term, but on a rare occasion, the AP has asked that you know that there's this term called equilibrium solution. All that means is you've got something with a slope of 0. So wherever you start, you just stay on that line. The point 1 comma 0, that one's down here. This one's a little trickier to sketch the equation for. You can see the slopes as we go to the right are getting a little flatter. Eventually they're going to approach that equilibrium spot. And then we're going to dip down as we go. We're going to eventually zero out. And we're going to kind of come back up. And it's going to look something like that. And as long as you're in the general shape on that graph, you're going to pick up the points. And again, they'll show you where the points are tagged, but usually they'll just tag 1 point to each of those graphs that we just sketched in. The last piece that they're asking us to do is the same thing as part B from the previous. And I'm just going to, because I know I'm going to need it, I'm going to write my y prime equation right down here, and then I'll scroll up. So they're not asking us to come up with a function. They do not want you to pull this thing apart and solve it right now. They are simply asking that you come up with a tangent line equation. So here's our tangent line equation. And they've given us an initial condition right there. They said, okay, this tangent line equation has a y of 0, it has an x of 1. And then we have an equation to get slope. So we have an equation that'll get us slope over here. So we're going to take our 1 for x, our 0 for y, and we're going to go ahead and get slope. It's going to be 1/3 times 4, in most math realms known as 4/3. So there we go. And y minus 0, we can write that as y, because anything minus 0 is just that thing. So you can leave it like this. If you really like the y equals mx plus b, you can distribute that 4/3 again. For convenience sake, I'm choosing to leave it like this because of what they're asking me to do. They are asking me to approximate f of 0.7. In other words, they want me to use the tangent line to make a guess as to what the function's worth. The fancy word for that is called linearization. And that is more of a fun fact than anything, but hey, we're here, we may as well have fun with it. So let's see, put in the 0.7. And again, typically what they try to do is they try to choose a numeric value that will make by hand computation relatively straightforward. So 0.7 minus 1 is negative 0.3. Well, negative 0.3 is really just negative 3/10. And of course, negative times positive is going to be a negative value. And let's see, a number of ways you can write this fraction. If you did like old school straight up multiplication across the top, you'd have a 12 and over 30. That can be simplified down to divide those both by 6. We'd have a negative 2/5, which if we chose to write it as a decimal would be negative 0.4. Technically speaking, these are all equivalent expressions. These two would be the most reduced. I would suggest you do your best to reduce it down to those, and then pick one of those two. So let's say we pick the negative 0.4. That is equal to the linearization approximation, or the approximate value for the function. And maybe actually let's be really specific here because we have a moment. If we're doing an approximate value, and I don't think they would nitpick on this on the AP, but we're saying wavy equal sign there, approximately equal to negative 0.4. But you could get by with an equal sign because the way they worded it, they said use it to make an approximation. So you'd be good on this one, I think, either way, where f of 0.7 is equal to negative 0.4. And again, the worksheet online for the solutions will show you where the points come from, but this video is just to show you how the solution would be put together.